All right, so welcome to our SparkNotes of the first semester of Compacted Math. This is where we're going through and just kind of talking about the highlights, the big points from each unit that we learned during our time from August to December. So this video, we're going to start with units 1 and 2. So unit 1 was when we first got to school and I said, hi, I'm Miss Smith, let's learn some math. And we started off as a recap unit from what you guys knew in 4th grade, which was a lot of the different types of forms of numbers, place value. And we talked about with decimals, how to compare, how to round, how to estimate, how to add and subtract those decimals. So let's start off with the highlights from unit 1. The very first thing, and I'm going to zoom in, so sorry for my pterodactyl is talking about the 3 different types of numbers, or the 3 different forms of numbers. So we have expanded form, word form, and standard form. I'm going to start with the word form because it should be the easiest. It's the one where the number is written in words. So 423, it's all spelled out in words. That is word form. Now, standard form is how you would just write a number. So if I told you to write down the number 423, you would write a 4, a 2, a 3. So this is just straight up numbers, exactly how it sounds is how we write it. And the last one is expanded form. And expanded form is where we break apart each of the digits and represent them with their place value. So 400 becomes 400. We add to it 20, 20, and we add to it 3. So word form, expanded form, standard form. And then we talked about the difference between place and value. We said a digit's place is the location and its value is what it's worth. So when we talk about place value, we're talking about what is it worth and where is it located. So then I gave us just this number, or not this number, these blanks here for us to fill in the place value title. So I'm going to turn mine sideways just so I've got some room and I can make it all fit. So the very farthest one, this is our thousands. And then we would have our 100. And then next, moving closer to the decimal, we have our tens. And then right next to our decimal, we have the ones, which we also call units. Then moving from the decimal, the closest one on the other side would be the tenths. Remember, we always over enunciate that, the THS. Then we have our hundredths and our thousandths. So anytime when we're looking at place value and we see that THS, that means it is a decimal. It's smaller than 1. Then we talked about comparing 2 decimals. So if I have the decimals 13 and 25 hundredths and 13 and 3/10, I'm going to look at the very first place where I notice that there is a number that is different. So they both have 13 in common, but in the tenths place, this one has a 2 and this one has a 3. The one that has the 3 is worth more. So I would say 13 and 25 hundredths is less than 13 and 3/10. Our next 2 numbers, 1 and 259 thousandths, 1 and 258 thousandths, where they are different is in the thousandths place. 9 is bigger than 8, so 1 and 259 thousandths is greater than 1 and 258 thousandths. And then last but not least, 489 and 3/10, 489 and 30 hundredths. Now, this 0 over here, if I got rid of it, it's not going to change the value of this number. It's what we call an unnecessary 0. So once I get rid of that 0, my numbers are the same, which means they are equal. Our next one, this one was all about rounding. So rounding, we're going to round this number 14 and 583 thousandths a couple different ways. We're going to round them to the following place values. So if I want to round it to the tenths, I see right now that I have a 5 in the tenths place. Now, I always want to look at the place to the right. So I see that I have an 8. And our rounding rules are if the number to the right is a 0 through 4, our number stays the same. I forgot how to spell same for a second. And then if it is a 5 through 9, our number gets rounded up 1. So since our number to the right is an 8, falls in between the 5 and 9, that means I need to round up, and that 5 is going to become a 6. So I get 14 and 6 tenths. Okay, I'm going to now do the hundredths. So I have an 8 in the hundredths place. To the right is a 3. So since it's between 0 and 4, it's going to stay the same. So this is going to be 14 and 58 hundredths. The thousandths, I have a 3 in the thousandths place right now, and there's nothing to the right of it, which means that really there's a 0 to the right of it. 0 tells me to stay the same, so it's 14 and 583 thousandths. And then our last spot it wants us to round to is the ones position. So I've got a 4 in the ones, a 5 to the right, so that 5 tells me to round up, so this just becomes 15. Now, the important thing to remember when rounding is we don't want to include unnecessary zeros. So I don't need to make, for example, on my tenths, it doesn't need to be 14 and 600 thousandths. It just stops at the tenths. And then our last little bit of Unit 1 was all about adding and subtracting decimals. And the most important thing that you have to do when you add and subtract with decimals is you have to make sure that you have lined up your decimals, that you are adding and subtracting the same place values. So I'm going to start with my first number, 461 and 25 hundredths. Then before I even write that second number, I'm going to go put a decimal right underneath. So my decimals are lined up. And I see that on the left of my decimal, I have a 0. On the right, it should look like 129. Now, when I add these together, I want to make sure that there are no numbers hanging out by themselves. So I'm going to use zeros as placeholders. Unnecessary zeros are okay here. So my decimal is going to get dropped straight down. I'm going to go ahead and do that now so I don't forget. And then I just add like normal. So I have 0 plus 9, which would be 9. 5 plus 2 is 7. 2 plus 1 is 3. 1 plus 0, 1. 6 plus 0 is 6. And 4 plus 0 is 4. So I get a final answer of 461 and 379 thousandths. Now, when I subtract, it's the same thing. I want to make sure my decimals are lined up. And it's important to remember whatever number comes first in a subtraction problem, that is the top number in our subtraction problem. So I'm going to start by writing 6 and 937 thousandths. I'm going to put that decimal there just to make sure, again, things are lined up. Should have a 2 on the left, 457 on the right. Okay, so when I subtract, I'm going to bring that decimal straight down, just like before. I have 7 minus 7, which is 0. 3 minus 5, I can't do, so I have to go borrow. My 9 becomes an 8. My 3 becomes a 13. So now this is 13 minus 5, which is 8. 8 minus 4, which is 4. My decimal's already there. And 6 minus 2, which is 4. So right now I have 4 and 480 thousandths. But remember, this is an unnecessary 0. I don't need it. So I get a final answer of 4 and 48 hundredths. All right, continuing on to Unit 2. Unit 2 was all about multiplication. So we looked at whole number times whole number multiplication, a whole number times a decimal times a decimal, what those different models look like, and then we ended with order of operations. So we're just going to start with just regular whole number times whole number multiplication and the steps that we go through there. So step number 1 is when we set up our problem, we want to put the number with the least digits on the bottom. Then we're going to multiply the entire top row by the ones place in the bottom number. Then you're going to think like a chicken. Remember, chickens scratch and they lay eggs. Then we're going to multiply the entire top row by the tens place in the bottom number. And then our last step is to add those partial products. So let's see what this looks like in action. So we already have it set up where the number with the least digits is on the bottom. We're going to multiply the entire top row by the ones place in the bottom number. So 3 is in the ones place. So 3 times 2 would give me 6. 3 times 8 would give me 24. So I write the 4, carry the 2. 3 times 4 gives me 12, plus 2 more is 14. Now, I have to think like a chicken. So I'm going to scratch out the ones, scratch out anything that I carried, and lay an egg. Now I'm going to multiply the entire top row by the tens place. So 2 times 2 is 4. 2 times 8 is 16. So I write the 6, carry the 1. 2 times 4 is 8, plus 1 more is 9. Our last step, add the partial products. So 6 plus 0 is 6. 4 plus 4 is 8. 4 plus 6 is 10. So write the 0, carry the 1. 1 plus 1 is 2, plus 9 is 11. And for our final answer, we want to make sure we write our number properly. So it's going to be 11,086. Now, when we multiply with decimals, everything looks the same. We just have 2 extra steps that we have to think of. So we're still going to put the number with the least digits on the bottom. That is still true. But then our new step 2 is then we're going to ignore the decimals. We pretend like they don't exist. We still multiply by the one in the number in the ones. If we need to, we think like a chicken, and then we multiply by the tens. Add partial products if we need to. But then our last step is, since we ignored the decimal, now we have to place the decimal back in our final answer. And in order to do that, we count the number of spaces that the decimal moved in both of our numbers. So I've already set it up where we've got our number with the least digits on the bottom. I'm going to ignore the decimals. So this problem looks like 451 times 9. And let's just multiply like we know how to do. So 9 times 1 is 9. 5 times 9 is 45. So write the 5, carry the 4. 4 times 9 is 36, plus 4 more gives me 40. Now, no need to think like a chicken because I only had 1 digit down here. So now I just need to place the decimal back in the product. So I moved the decimal 2 times in the first number, 1 in the second number, for a total of 3 spaces. So 1, 2, 3. So I get a final answer of 4 and 59 thousandths. Okay, so when I look at my multiplication models, there are 2 different types of models that we have. The first type of model is going to be when I have a whole number times a decimal. The other way that I can read this is by having groups. So I could reread this as 4 groups of 11 hundredths. Sorry, I'm looking for my markers and couldn't multitask. So what this means is I have 4 separate groups and they each contain 11 hundredths. So I'm going to use my markers to show different. So that would be 1 group of 11 hundredths. This would be a second group of 11 hundredths. This would be a third group of 11 hundredths. And our final group of 11 hundredths. For a total of 44 hundredths. Okay, we're going to do the same thing for our next one because I have another whole number times a decimal. So I can reread this as 6 groups of 2 tenths. So I'm going to use my colors again. So this would be 1 group of 2 tenths, 2 groups of 2 tenths, 3 groups of 3 tenths, 4 groups of 4 tenths, or 2 tenths, sorry, 5 groups of 2 tenths, and 6 groups of 2 tenths. Now, we did have to use more than 1 tenth or hundredths model, which is okay. This represents 1 whole, and I have 2 tenths on the other one for a final answer of 1 and 2 tenths. Now, our next type of model is when I have a decimal times a decimal. So I can't read this as groups because it wouldn't make sense to say that I have 3 tenths groups of 5 tenths. So what I'm going to do is I'm going to say that my 3 tenths is going to be represented by my yellow. My 5 tenths is going to be represented by my blue. Now, I'm going to make my yellow lines go vertically. So I'm going to shade in 3 tenths vertically. And then I'm going to make my 5 tenths go horizontally. And my answer is wherever those 2 colors overlap. So right here is where they overlap. And they overlap in 15 squares. So 15 hundredths is my final answer. Our next type of multiplication model that we looked at is called a multiplication quick pick. So remember, quick picks are meant to be quick drawings, to where if I draw just a flat out square, that represents the ones. If I draw just a straight up and down line, that represents tenths. And if I draw just a dot or a square, just something singular by itself, that represents hundredths. So Quick picks are only shown for a whole number times a decimal. That's it. There's no decimal and decimal. It's just a whole number times a decimal. So the whole number represents how many groups you have. So that's always the one that I tend to start with. So I see that I have 2 groups here. And inside each group, I have 4 rods. Well, since those rods represent tenths, that means I have 4 tenths. So this problem here is 2 times 4 tenths, which gives me a final answer of 8 tenths. My next group here, or my next problem, I see 1, 2, 3 separate groups. In each group, I see 1/10 and 1, 2, 3 hundredths. So that would be 13 hundredths. And that gives me a total of 39 hundredths. My last one again, I have 1, 2, 3 groups. Inside each group, I see 5 hundredths for a total of 15 hundredths. All right, moving on to our next page where we talked about our order of operations and we sang our song that goes, it's fun to do the G-E-M-A. We said the G stands for grouping. We said there were 2 types of grouping. We had parentheses and we had brackets. Our E stands for exponents, and we'll recap more of the exponents in just a second up here at the top. M stood for multiplicative. We have 2 things that are multiplicative. Those are multiplication and division. A stands for additive. We have 2 things that are additive, adding and subtracting. Remember, if I have multiplication and division in the same problem, so if it's the same level, I always start on the left, work my way to the right. Same thing, I start on the left, work my way to the right. So I'm going to jump back up here at the top for exponents. So when we talk about exponents show us repeated multiplication. The big number in an exponent, like this one right here, is called the base. And the tiny number is the exponent. Now, when I have something that looks like this, there are 2 ways that I can read this, but either way, I always start with the base. So I could read this as 2 to the 4th power or 2 to the power of 4. And what this would look like in expanded form is, since it shows us repeated multiplication, this would be the same thing as 2 times 2 times 2 times 2. So if I have this problem right here, I'm going to zoom in again. I have 3 to the power of 3, or 3 to the 3rd power, or I can read it as 3 cubed. That's the same thing as 3 times 3 times 3. Now, I have to take this one step at a time. Follow your order of operations. It's all multiplicative, so start on the left. 3 times 3 would give me 9, and 3 times 9 gives me a final answer of 27. 12 to the power of 1, well, anything to the power of 1 is just going to be the base, so this would be 12. 6 to the power of 0, anything to the power of 0 is just 1. And then 2 to the power of 5 is the same thing as 2 times 2 times 2 times 2 times 2. So 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. And 16 times 2 gives me 32. So let's look at a few problems. I'm going to start with the first one. So I see that I have 5 plus 6 times, parentheses, 5 plus 8. So if I follow my order of operations, I do see some grouping. So I need to solve whatever is inside of the grouping first. So that would be 5 plus 8, which gives me 13. Now, I don't have to bring the parentheses back down because I've solved everything that's inside of them. They can disappear. So then I'm going to copy down all the stuff that I did not use. I have no more parentheses. I have no more grouping. I don't see any exponents, but I do have something that's multiplicative. I have 6 times 13. 6 times 13 gives me 78. And then my last step is just 78 plus 5, which would give me 83 for a final answer. Our next problem, I have parentheses, 10 minus 3 to the power of 2, close parentheses, times 5 plus 7. According to order of operations, I start with the grouping first, but inside of the grouping, I see 2 different things. I see something that's additive, and I see an exponent. Well, order of operations says I've got to start with that exponent first. So 3 to the power of 2 is the same thing as 3 times 3, which would give me 9. So I need to copy down everything that I haven't done. And since I haven't finished everything in the parentheses, I have to still put those back. So since I still have parentheses, my next step would be 10 minus 9, which would give me 1. And now that I'm done with everything inside of there, my parentheses disappear. So this would be 1 times 5 plus 7. My next step would be 1 times 5, which just gives me 5, and 5 plus 7 for a final answer of 12.